Lens. What is lens? A lens is a piece of a refractive medium bounded by two surfaces, at least one of which is a curved surface. Lenses are of two types. First is convex or converging lens. It is thicker at the center than at the edges. It converges a parallel beam of light on the reflection through it. It has a real focus. Number two is concave or diverging lens. It is called concave or diverging lens. It is thinner at the center than at the edges. It diverges in parallel beam of light on refraction through it. It has virtual focus. Definitions in connection with spherical lens. Center of curvature. Firstly, center of curvature. The center of curvature of the surface of a lens is center of the sphere of which it forms a part, because a lens has two surfaces, so it has two centers of curvature. Number two is radius of curvature. That was center of curvature, now the radius of curvature. The radius of curvature of the surface of a lens is radius of the sphere of which the surface forms a part. Number three, principal axis. It is the line passing through the two centers of curvature of the lens. Principal axis is the line passing through the two centers of curvature of the lens. Number four is principal focus. A narrow beam of light parallel to the principal axis either converges to a point or appears to diverge from a point on the principal axis after refraction through the lens. This point is called the principal focus. A lens has two principal foci. Next is optical center. What is optical center? It is the point situated within the lens through which a ray of light passes undeviated. Next is focal length. What is focal length? It is the distance between the principal focus and the optical center of the lens. It is the distance between the principal focus and the optical center of the lens. Next is aperture. What is aperture? It is the diameter of the circular boundary of the lens. It is the diameter of the circular boundary of the lens. Next is new Cartesian sign convention for spherical lenses. Sign convention. I am telling about sign convention. All distances are measured from the optical center of the lens. All distances are measured from the optical center. Second is the distances measured in the direction of incident light are taken as positive. Next is the distances measured in the opposite direction of incident light are taken as negative. Next is heights measured upwards and perpendicular to the principal axis are taken as positive. And next, heights measured downwards and perpendicular to the principal axis are taken as negative. In this sign convention, the focal length of a converging lens is positive and that of a diverging lens is negative. Refraction through a spherical surface. A surface which forms part of a sphere of a transparent refracting material is called a spherical refracting surface. A surface which forms part of a sphere of a transparent refracting material is called the spherical refracting surface. Next is refraction from a rarer to denser medium. Refraction from a rarer to denser medium. When a ray of light travels from a rarer medium of index mu1 to the denser medium of refractive index mu2, then the radius of curvature r and the relation between the object distance u and the image distance v is mu2 upon v minus mu1 upon u equal to mu2 minus mu1 upon r. If the rarer medium is air, then mu1 equal to 1 and mu2 equal to mu, then it will be mu upon v minus 1 upon u equal to mu minus 1 upon r. Next is refraction from a denser to rarer medium. When an object is placed in a denser medium, the relation between u and v can be obtained by interchanging mu1 and mu2, and it will be mu1 upon v minus mu2 upon v equal to mu1 minus mu2 upon r. Next is power of a spherical refracting surface. What is the power? It is given by P equal to mu2 minus mu1 upon r, and that will be equal to mu minus 1 upon r for air. When r is measured in meter, the power of a convex surface is positive. The power of a convex surface is positive, and that of a concave surface is negative. The principal focal length of a spherical surface. Principal focal length. First principal focal length. It is the distance from a point. It is a distance of a point from the pole of the surface at which, if an object is placed, the image is formed at infinity. First principal focal. What is the first principal focal? It is the distance of a point from the pole. It is a distance of a point from the pole at which, if an object is placed, the image is formed at infinity. The first principal focal length f1 equal to minus mu1 r upon mu2 minus mu1. Second is second principal focal length. It is the distance of a point. It is the distance of a point from the pole at which the image of an object at infinity is formed. Second principal focal length will be equal to f2 equal to mu2 r upon mu2 minus mu1. Lens maker's formula. What is lens maker's formula? This formula relates the focal length f to the refractive index mu and the radii of curvature r1 and r2. 1 upon f equal to mu2 minus mu1 upon mu1 under the bracket 1 upon r1 minus 1 upon r2. For the lens placed in air, 1 upon f equal to mu minus 1 under the bracket 1 upon r1 minus 1 upon r2. Now, thin lens formula. This formula gives the relation between object distance u, image distance v, and the focal length f of a spherical lens, convex or concave, for small aperture. 1 upon v minus 1 upon u equal to 1 upon f. Linear magnification produced by a lens. It is the ratio of the size of the image formed by a lens to the size of the object. Magnification will be equal to size of the image upon size of the object, and it will be equal to m upon h2 upon h1, and it will be equal to v upon u, and f equal to f plus u, and it will be equal to f minus v upon f. When m is positive, the image is virtual and erect. When m is negative, the image is real and inverted. Next is power of a lens. The power of a lens is defined as the reciprocal of its focal length. Reciprocal of focal length is called the power. It is expressed in P equal to 1 upon F in meter. SI unit of power is per meter, and it is also called the diopter D. 1 diopter is the power of a lens. Whose principal focal length is 1 meter. 1 diopter is the power of a lens whose principal focal length is 1 meter. P equal to 1 upon F, and it will be equal to mu minus 1 under the bracket 1 upon R1 minus 1 upon R2. Now, refraction through a prism. When a ray of light is refracted through a prism. The sum of angle of incidence I1 and the angle of emergence I2 is equal to the sum of the angle of prism A and the angle of deviation delta. A plus delta equal to I1 plus I2 and A equal to R1 plus R2, where R1 and R2 are the corresponding angles of refraction. Relation between the refractive index and the angle of minimum deviation. The minimum value of the angle of deviation suffered by a ray on passing through a prism is called the angle of minimum deviation and is denoted by delta m. The minimum value of angle of deviation suffered by a ray on passing through a prism is called the angle of minimum deviation and is denoted by delta m. When a ray of light suffers minimum deviation, that I1 equal to I2 and R1 equal to R2 and delta equal to delta m. A plus delta m equal to I plus I, that will be equal to 2I. Then I equal to A plus delta m upon 2. And A equal to R plus R, that will be equal to 2. A equal to 2R. Then R equal to A upon 2. Then refractive index mu can be written as sin I upon sin R. Sin I, in place of I will put A plus delta m upon 2. And in place of R, I will put A upon 2, then sin A plus delta m upon 2 upon sin A upon 2. Deviation produced by a prism of small angle. Deviation produced by a prism of small angle. It does not depend on the angle of incidence and is given by delta equal to mu minus 1 into A. Dispersion. What is dispersion? The splitting of white light into its constituent colors when it passes through a glass prism is called the dispersion. The splitting of white light into its constituent colors when it passes through a glass prism is called the dispersion. The dispersion of light occurs because the refractive index of the prism material is different for different wavelengths. Next is angular dispersion. What is angular dispersion? The angular dispersion between the two extreme colors, violet and red, in the spectrum is called the angular dispersion. Next is angular dispersion. The angular separation between the two extreme colors, violet and red, in the spectrum is called the angular dispersion. Angular dispersion equal to delta V minus delta R, and it will be equal to mu under the bracket mu V minus 1 into A minus mu R minus 1 under the bracket A, and that will be equal to mu V minus mu R into A. Next is dispersion power. What is dispersion power? It is the ability of the prism material to cause dispersion. It is the ability of the prism material to cause dispersion and is defined as the ratio of the angular dispersion to the mean deviation. Dispersion power equal to angular dispersion upon mean deviation. Omega. Omega is called the angular dispersion, and this is delta V minus delta R upon delta. That will be equal to mu V minus 1 under the bracket A minus under the bracket mu R minus 1 into A upon under the bracket mu minus 1 into A, and it will be equal to mu V minus mu R upon mu minus 1. Here delta equal to delta V plus delta R upon 2 and mu equal to mu V plus mu R upon 2. Blue color of sky. Why sky looks blue? According to Rayleigh's law of scattering, the intensity of light of wavelength lambda present in the scattering light is inversely proportional to the force power of the wavelength. That will be equal to I directly proportional to 1 upon lambda to power 4. So, blue color of sunlight is scattered more by the atmosphere